This chapter is about sets, so I thought we'd start with an introduction and some just basic vocabulary you're going to need for this chapter to make a lot of sense. So our first definition we're going to talk about is a set. And a set is simply a collection of objects. I want you to note that the set could be anything. So just because we're math class doesn't mean it's numbers. It could be letters, it could be people, it could be shoes, whatever you wanted. If you had a collection of them, then that makes a set. Anything that's an object belonging to a set, then we call an element. Notationally, we generally use capital letters for sets, and then we use these brackets to denote sets. So, for example, if I wanted to say the set of seasons is S, then I would have brackets, and then the set would be winter, spring, summer, and fall. When you do a set, order doesn't matter. So I wrote winter, spring, summer, fall. I could have written fall, summer, spring, winter. So order isn't important, and repetition doesn't matter. So if I had written winter, 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 spring, 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 summer, 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 fall, 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 it's the same. So don't get confused with order. No big deal. Repetition, no big deal. Right. So again, special notes about sets. For sets, order doesn't matter. So if I write A is 1, 2, 3, it's the same as A is 3, 1, 2. Think of it this way. In our class, we have a list, right? There's a list of everyone that's enrolled in our class, but I have no idea who enrolled first, who enrolled last. It just matters that you're in this class. So how you got here doesn't matter. It just matters that you're belonging to this set. So same thing with this set B, which is 4, 5, 6, 7. That's the same as 5, 4, 6, 4, 5, 7, 5, 4, 6. It's kind of like a store carrying a brand of soda like Coke. If the store has 1 bottle or 100 bottles, they still carry Coke as a product. So we don't care how many bottles they have, we just care if they sell it or not. Next thing we need to talk about is well-defined. So well-defined means that you can determine elements that belong to a set. So for example, if A was the set of days in a week, I would know what belongs there, Sunday, Monday, Tuesday, but I didn't have to write them all out. I just had to say, can I tell if they're there or not? Or if I said R is the set of all rivers in Florida. I can tell you, I for one cannot name all the rivers that are in Florida. I can tell you Hillsborough because that's an easy one, but I can look it up. So the set needs to be described in a way that someone could do research to decide if the elements belong there or not. So it doesn't mean just because you don't know the elements in the set that it's not well defined. Say that we had T is a set of all natural numbers greater than 3. That's well defined. Right? We could decide if something's bigger than 3 or not, and we can decide if something's a natural number or not. Even if right now you don't know what a natural number is, we're going to get there, but we could determine it. So we could also say H is a set of all students that attend HCC. Absolutely. No one knows that set, right? Could we look it up? Yes, we can see if someone's enrolled at HCC or not, but this is like 40,000 some students. There's not this running list that anybody knows in their head, but you can always make that determination and look it up. Not well-defined. Not well-defined means the set is not described clearly enough to understand what elements make up the set. So, like say we had B as a set of beautiful cars made by BMW. That's an opinion. Everyone may not have the same definition of beautiful, so this set is not well-defined. E could be the set of fun math classes. And I'm sure you are with me on this one. I think all math classes are fun, right? So you might not feel the same way. Everyone has a different opinion about math and what is fun. Many people think there are no fun math classes, whereas I generally love teaching math and think like calculus is awesome. So that, because there's that opinion of fun, we can't say that that's well defined. Okay. Additional things we're going to want to know. Universal set. So a universal set, and we use a U to symbolize it, is the set that contains all elements for any specified set we're discussing. So once we define a set, we're essentially defining our universe. So for example, if we are dealing with H was the set of all HCC students, then we know we're only talking about students that go to HCC. This becomes our universe. Or if B was the set of all NBA teams, then we know we are only discussing basketball and not other sports. Empty set is the set containing nothing. Right? So we call it empty or null, and you have 2 choices for how to symbolize it. So you could just do the set notation and put nothing in it, or you can do the empty set like a circle with a line through it all by itself. Do one or the other, do not do both. So A could be the set of all NBA teams in Tampa. And currently, Tampa does not have an NBA team, so that makes this an empty set. Another thing, M could be the sets of all months of the year that start with the letter W. So here's what I'm thinking. You're going through your head right now with the set of months, right? You should be going January, February, March, April, May, June, July, and you go through, and you can see that M would be empty because you're never going to come across a month that starts with the letter W. All right. So let's talk about some number sets that are going to be important to us as we get through this chapter. The first set is called the natural numbers, and we use N for natural, not N for numbers, N for natural. And natural is if we were sitting in a room and there are a bunch of people in it and we wanted to know how many people there were, we would start counting them. And as we count 1, 2, 3. That's natural. That's a normal way of counting. So naturals are 1, 2, 3. So it starts at 1 and it continues growing. No decimals, no negatives, no fractions, just normal numbers like you count. Whole numbers, very close to that, and we call W for whole, starts with 0. So we could say, like, how many dogs are in the room? And we could have 0, we could have 1, we could have 2, right? And so we have that option that there could be nothing. So we have that additional of 0. Integers get even bigger. So integers now introduce negatives. But again, not decimals yet, not fractions yet. So it goes on in both directions, but -3, -2, -1, 0, 1, 2, 3, on and on. Where it gets trickier is when we start talking about rationals. So rationals is anything that I can form by a fraction. So to make a fraction, I say P over Q. P and Q are integers, which means I can have positives or negatives, and Q can't be 0. So rationals are our biggest set we've talked about so far, and they can be any number you can write as a fraction, like a half or -3/4. But even if I did 10 over 5, which we know is 2, it's still considered rational because you can write it as a fraction. So rationals were Q kind of thinking like quotient. Irrationals are I for irrational. And irrational is any number that is not rational. Kind of makes sense. Either it's rational or it's not. These are weird numbers. These are numbers like pi, square root of 3, square root of 3 plus 2, right? So if I can find a number that I can't write as a ratio, I can't write it just without decimals, or if the decimal repeats forever like it does for pi, then we're going to call that irrational. Then reals. Reals is the really big set. Reals is put it all together. So real is any number that is either rational or irrational. And I kind of think that's most things you can think about. So it can go back to 1, 2, 3. It can be 1/2. It could be the square root of 2. It could be the square root of 2 plus a half. What it doesn't include are things like complex numbers, like the square root of -1. We're never talking about that in this class, so don't even worry about it. So if you're thinking, I learned this thing back in school, doesn't matter. If it's not on this page, we're not going to talk about it.